Okay, in this video, 9.3, factoring a trinomial when a equals 1. So your objective, I will be able to factor trinomials through the use of the product sum method. Okay, so what is a trinomial? Well, if a binomial had two terms, a trinomial, like a tricycle, having three wheels, has three terms. The standard form of a trinomial looks like this. And it's going to be important to be familiar with this because we're going to pull out this A, B, and C. So list the A, B, and C for these trinomials. So if there's nothing in front of the x squared, that means there's just a 1 there. So our A equals 1. Our B equals 9, and our C equals 20. And you'll notice that we're focusing today on when A equals 1. Okay? All right, you go pause the video and give it a try. Call these all A. I'll fix it on yours. Let's call this B and this one C. Give this a try and try to find out what the A, B, and C are for each of these. So pause the video and then rejoin me when you're ready to check your answers. Okay, check your answers. Hopefully you came up with the same thing that I did here. All right, this is going to lead us into the product sum method, and I use a little kind of graphic organizer. Every teacher teaches this differently, but I've found that by having this little graphic, it's just a good way to brainstorm for your factors. And I'll show you what that means in just a second, but I call it the I-bar method, and you'll see why in just a moment. So your first step here is to determine the A, B, and C from our example here. So our A is 1, our B is 18, and our C is 80. Now we're going to set up an I-bar. So this is what I was talking about. That's kind of, I know a few teachers that do it, but you might not see this a whole bunch, but I just think it's helpful for finding the numbers that you need in step 3. So you set up an I-bar, and the reason it's called an I-bar is because, well, if it wasn't for this font, capital I's usually look like this. So on the top here, you're going to put in your A times C, and on the bottom, you're going to put in B, and we'll talk about what goes in the middle here in just a moment. So let's make a nice big I-bar off to the right here that we can use, and let's fill it in with A times C. So I'm going to take 1 times 80. And for this set of notes, you're going to see that we're always going to have the A times C is just going to be C because we are focusing when A equals 1. Eventually, A will not always going to be equal to 1, but for now it is. So let's just get used to A times C, and yes, it's always just going to be C, but that'll change eventually. Okay, on the bottom, we're just going to put B, which is 18. All right, step number 3, brainstorm factors that multiply to A times C and add to B. So to kind of have a graphic here, and you won't have to write this in every time, but these numbers we're going to list here are going to multiply, and that's where the word product comes from in the product sum method. So they're going to multiply to this number, and then they're going to add, so sum, to this number. All right, then circle the magic numbers, and that's what I call them. So let's go through and do that process. All right, so we're trying to come up with factors of 80. So factors because they multiply to 80, but that are going to add to 18. Okay, so for instance, 1 times 80 does multiply to 80, but 80 plus 1 is going to be 81, so that's not going to help us out here. So that's not it. 2 times what equals 80? Well, 2 times 40 equals 80, but they're not going to add or subtract. Once we get into negatives, we want to be thinking adding or subtracting. They do not add or subtract to 18. I'm going to start jumping ahead because I can see that 1, 2 is not getting me very close. 4 isn't going to be very close. So how about 5? Okay, so 5 times what equals 80? 5 times 16 equals 80. But can I add or subtract 5 and 16 and get 18? No, if I add them together, I'm going to get 21. If I subtract them, I'm going to get 11. So that doesn't work out for me. How about 8 and 10? Okay, 8 and 10 do multiply to 80, and they also multiply to 18. So these are my magic numbers. I'm going to go ahead and circle them. Sometimes this process is going to be short, sometimes it's going to be long. You can use your calculator to guess and check all the different factors to see which ones work. And now we can write our solution. So our solution, you first write with 2 sets of parentheses. So let's go ahead and write 2 sets of parentheses, just like that. Okay, we want to put an X on the left in both sets. So here we go. I'm going to put an X on the left of this parentheses and an X on the left of this set of parentheses. Okay, finally, the magic numbers with their signs on the right of both. So with their signs is going to be pretty important as we move forward. We start getting some negatives in our problems here. So the magic numbers with their signs, well, they're both positive. So that means I'm going to put in plus 8 in one and plus 10 in the other. Okay, so my final answer here, this fully factored trinomial, is x plus 8 times x plus 10. And it doesn't matter which one comes first. That does not look like a 10 for some reason. Let's fix that. It doesn't matter if you have x plus 10 times x plus 8, because when we multiply, it doesn't matter which order. But you should have these two binomials together here. So last step here, multiply back together to check. So let's go ahead and do that. I'm going to multiply my x times my x, and I get x squared. Then I'm going to multiply my x times my 10, positive 10x. Then 8 times x plus 8x, and then 8 times 10 is 80. I'm always going to be able to combine these middle terms here. They both have an x on them, so I get x squared plus 18x plus 80. And let's just double check that that is what we started with, and it is. All right, so I'm going to do 4 problems, and then I left 2 for you to try. So please give them a try. It's just good to, as soon as you've seen it, try it on your own. If you're already feeling confident on doing this at any point, pause the video and give some of these a try on your own also. Also, when you get to class, I can kind of tell where we are as a group based on what answers we're getting here. All right, so let's find our A, B, and C in this. So my A equals 1, my B equals 9, and my C equals 20. I'm now going to set up my I-bar. 1 times 20, so my A times C goes on top, with my B on the bottom, and now I need to come up with factors that multiply to 20 and add to 9. So 1 and 2 and 10, that's what I meant to say, 2 and 10. All right, 2 and 10 multiply to 20. They're not going to add or subtract to 9, so that's not going to work out for me. Next, I'm going to try 4 and 5. 4 and 5 do multiply to 20, and they add to 9. So there we go. I'm going to set up my 2 sets of parentheses. X is on the left. Both of these are positive, so I'm going to have plus 4 and plus 5. But if you do it the other way, plus 5 and then plus 4, that is totally fine. And then last here, this is the answer. We're done. But I like to put on that last part there that you should actually check it. Why not? So it's multiplying back together. X times x is x squared. X times 5 is 5x. 4 times x is 4x. And 4 times 5 is 20. Combine the middle terms, and I get x squared plus 9x plus 20. So check, I did do this correctly. All right, things are going to get a little more complicated here because now we have a negative in there, but it's still the same steps. So we have A equals 1, B equals negative 14, and C equals 49. I'm going to draw a line in here to separate my work clearly. Set up my I-bar. 1 times 49 is 49. And then B is now negative 14. So far, all of them have been positive on the top and the bottom here. All right, well, finding the factors to 49 is going to be pretty easy because there is one factor other than 1 and 49. And we already can tell 1 and 49 are not going to add or subtract to negative 14. So how about 7 and 7? All right, 7 and 7 multiply to 49. And they would add to 14, but we need something to happen here because 7 plus 7 equals a positive 14. And I don't want a positive 14, I want a negative 14. And if I make one of them negative, so let's try that. If I make one of them negative, negative 7 times positive 7 would give me a negative 49. So that's not going to work. And a negative 7 plus 7 would be a 0. But if I make them both negative, well, now I have negative 7 times negative 7 equals 49 because a negative times a negative is a positive. And negative 7 plus negative 7 does equal negative 14. So there we go. There's my magic numbers. I forgot to circle them in the last one here. Those were the ones in the last one. All right, so I'm going to lay down x, and you remember to bring the sign. So it's minus 7, minus 7. Okay, just for this video, I'm not going to go back and check this, but I want to encourage you to check your work to make sure you're coming up with the right answer. All right, if you're feeling confident, go ahead and pause and give this one a try, and then rejoin when you're ready, or just follow along if you're not feeling like you're there yet. So my A equals 1, my B equals 5, and my C equals negative 14. Setting up my I-bar, 1 times negative 14 is negative 14. My B is 5. I see that I have a negative in there, so now let's start coming up with the factors. And as we're doing it, we're just going to see, do they add or subtract to 5? Because when I say subtract, I mean we can throw some negatives in there, and now my sum becomes a subtraction problem. All right, so 1 and 14 do not add or subtract to 5, so that's not going to work out. 2 and 7, well, if I add 7, I would get 9. If I subtract 2 and 7, I would get 5. So I just need to figure out where that negative goes then to make sure that it's going to add to a positive 5. If I make my 7 negative, so let's think about this. Don't write this down because I just want to think about this. I'm just going to use this as a scratch area for a moment. If I have 2 minus 7, that's going to give me negative 5. That's not what I'm looking for. As opposed to negative 2 plus 7. Well, negative 2 plus 7 is going to give me a positive 5. So it looks like I need my negative right there. Get rid of this work here. And I found my magic numbers. Negative 2 and 7. So I have x minus 2 and x plus 7. All right, last one I'm going to do in this video before I let you try a couple on your own. Well, I do not have a 1 here. I have something here. I have a 2. So what are we going to do about this? Well, when this happens, the first thing you should try is try to factor out a greatest common factor between all these terms. So is there a GCF? Well, there is. 2 can come out of all of these. So let's go ahead and factor that out. So I'm going to pull a 2 out. And I divide 2x squared by 2, and I'm left with x squared. I divide negative 12x by 2, and I'm left with a negative 6x. And I divide 10 by 2, and I get a 5. Well, now I'm back to a problem where I do have a 1 on the x squared, and now I can just continue as I was before. I need to multiply to 5 and add to negative 6. The factors in 5 are just 1 and 5. So 1 times 5 equals 5, but how am I going to get it to be a negative 6? Well, if I put a negative on both of them, -1 times -5 equals +5, and -1 plus -5 equals -6. So now I'm going to write my whole factored form here of this equation, but don't forget the 2. We didn't get rid of it. We just factored it out. It still needs to all be part of it. So 2 times x minus 1 and x minus 5. There we go. This is the full answer. Keep that 2 in there. All right, couple for you to try. Notice I didn't give you anything with a GCF, so you're just going to be using the I-bar method. Just try your best, see what you come up with. Thanks for watching.